Hello, I'm Dr. Christian Macedonia. Today I present a parameter-free derivation of the inverse fine structure constant derived purely from information-theoretic constraints using Octonions. No fitting, just pure mathematical derivation. If you would like to follow along or review the math, you can download this poster at thektproject.org. For a century, standard physics has treated alpha as a random dial setting. Richard Feynman famously called it a magic number with no understanding by man. But as David Hilbert said, we must know, we will know. No mysticism, just answers that math permits. Under the theoretical framework of this presentation, inverse alpha is not a constant. It is a channel function, a point of cohomological transition between manifolds, as described by both Steiner and Frobenius. Not a mystery, but mathematically predictable. This poster details our core claim, a derivation that aligns seamlessly with CODATA limits. It provides a complete formula and, crucially, a list of falsifiable experimental predictions. Most importantly, we don't start with particles, we start with logic. We rely on 7 core axioms, including triadic closure and totality, or computability. If the universe computes, it cannot crash. It must strictly follow these rules. Balanced change requires 3 flux states. By Hurwitz's theorem, observing a 4D reality requires 8D substrate of Octonions. Because Octonions are non-associative, operations must be eigenvector transformations to prevent information loss. Using the Fano plane, we derive exactly 42 basic eigenvectors. 7 associative quaternion lines times 6 ordered products strictly limit us to 42 primitive operations. This is an exhaustive mathematical necessity. We've verified this 4 independent ways: Fano walks, Markov models, Pascal-Fano overlays, and Navier-Stokes eigenvalue analysis. All 4 independent methods recover the identical 42-channel basis. This table is the machine code, as it were, of the substrate. These 42 obligate eigenvectors of an 8D to 4D bijection map the discrete deterministic layer strictly below Bell's theorem. So why the integer 137? It is the exact combinatorial channel capacity to bijectively map 8 dimensions to 4, minus the triadic closure overhead. In the 8-dimensional substrate, it is a pure combinatoric integer. And why the fraction just above 137? A bijective channel mapping a larger space to a smaller one must have memory. As Shannon proved, you cannot have a memoryless projection. The X term you see in that state memory cost, that's the entropy tax. In our formula, the log-log term represents structure of the structure. In the denominator, the dot product of 42 times 7 literally shows how the 42 eigenstates and the 7 Fano lines echo entirely through the derivation. But perhaps the most profound implication of this mathematics is what it tells us about time. Solving for n operations multiplied by Planck time yields 13.8 billion years. This is not a temporal origin point, but a dimensionless saturation depth of eigenstate closure. The universe is bounded by a computational depth limit, which is exactly why we see fully formed early galaxies after the so-called Big Bang. So, when we account for phase accumulation, memory cost, and geometric closure, we arrive at our final parameter-free prediction, 137.035999143 from our final equation, landing within 1.6 sigma of the 2022 CODATA standard. All code, apps, and papers are available at thektproject.org. I invite you to rigorously review the derivations, and I want to thank you for watching. Structural critiques are always welcome.